So next we are looking at the magnetic field produced by the solenoid, the shape of it, right? So you guys understand what is a solenoid, right? It's a quite simple device. So you have insulated copper wire being wrapped around a cylinder. So it is closely wrapped, and to illustrate, we have this, right? A simple illustration. So now we have two different cases. So in the first case, I have the battery connected in a traditional way, right? Generally, this is how you guys are used to look at. So this is how it is connected. Over here, the difference is the battery connection. The same solenoid, but the battery connection is different. So we have the current going in this manner. So this is front, and that's gone back. So that's why I indicated with dotted line over here. Okay, so here, and here. Right? So let me erase all of this. We need space to draw the magnetic field. See, if I have a magnet and I happen to place one more magnet, north, south, north, south, north, south, north, and south, how will be the magnetic field? It will act like a single bar magnet, is it not? And so you get a magnetic field in this manner. Right? So if you guys not able to remember, and if you want proof, we have this video which we have seen before. So have a look at this video. So remember this, right? We had two cylinder magnets placed in this manner, and we saw the magnetic field. It acted as if there's a single magnet, right? That was the intention of keeping that not cardboard, that wooden plank, and on that I made you guys see that, right? It doesn't matter how many magnets are there. If you joint it or let them attract each other, whatever that is, and you see many magnets over here, they act like a single magnet, right? The effect is so. So why is that I'm telling over here is, see, each loop will act like that. A thin magnet placed close to each other. So what will happen? You have thin set of magnets which are joined one in after another. So that is one of the reason I told you we have to wrap the wire in particular way and in particular fashion so that this effect can be seen. So as a whole, they create a magnetic field. That is one thing that you guys need to understand. So one thing which we can be sure of is the magnetic field lines will be straight in the middle, right? Because we know a circular loop creates a straight magnetic field in the middle. So as a whole, it will be straight. And here what happens somewhere around the ends, not almost at the ends, there will be a bit bent, something like this, right? We can expect some structure like that. Okay. So obviously this will loop back. Magnetic field are continuous and unbroken. So it will look like that. Same thing at the other end also. So it will be a bit kind of bumpy. Make sense? So almost near the center, it will be something like this. Okay, so that will be a basic structure, right? So here too, I have the batteries other way around, but here too we are using the same solenoid. So when we switch on, so current will go down, up, down, up, down, up, down, up, and down. So it's opposite to this, right? Make that observation first. but the magnetic field structure will remain the same. So I can just copy and paste, and yes, we have the similar magnetic field. So what will differ though? See, magnetic fields are vector quantities. So this kind of talks about the magnitude, but we need to talk about the direction also. So to talk about the direction, I have things over here, right? So this is, I mean, if you, the way I drew, it was for many people, it's difficult. So you guys can write this as your answer, right? Draw a solenoid and its magnetic field produced by it and all of that. You can draw this in your exam. So this is for your exam. But if you're able to draw the way I did, that is also pretty good. If not straightforward, you can draw this. Okay. So I have a small question. So I've indicated the magnetic field and everything. I'll explain how is it so and why is it so, and how you guys can determine. So my question is, here in this case, I've determined that you have a magnetic field in this way, going around in this way, right, in this fashion. And here it will be the other way around. Actually, I can do this. So here it will be the other way around, something like this, right? Just the opposite. That's it. So my question to you guys is, you have the compass needles, is it not? Right? Which end is south and which end is north? Is it this way or this way? Basically, is it this or this? Is it this or this? Option 1, option 2. Option 1, option 2. Okay, it's kind of very simple. By looking at it, you can tell it, but still, I want you guys to think about it. So I have an actual solenoid, which you guys already saw a photo of it. So I'll show you the working of it, right? And again, it's not a very strong solenoid, so the deflection is very minute. So you guys have to keep that in mind, right? So please watch the video. So again, you need not, there is no clue over there. You need not think hard from that video. I just wanted you guys to see a solenoid working, right? So now, clearly, this end has to be south end, right? So the north will point in this way because south end will attract the north. And here, clearly the north end, so it will attract the south. So it will point this way. So answer over here is option 1 and here is option 2. So how did I determine that? Simple. What you guys can do is you can think of this as a bar magnet. Let me change the color. Something like this. Okay, that was too much. How come I didn't miss anything? Anyways, it doesn't matter. You can think of this as a bar magnet, right? So here the magnetic field is coming out and here the magnetic field is going in. So thus this making this end as what? Yes, south end, right? And this end will be north end. And here on a similar line, think of imaginary magnetic, not magnetic, sorry, magnet, bar magnet. So you can see the magnet field coming out over here, and here it's going in, right? So this will be what? This will be north end, so attracting the south, and this will be south end, right? Attracting north. Okay, now how do we determine? Looking at a diagram, how do we determine? So let me go back to this diagram. See, if I happen to stand over here, or anyone happens to stand over here, what kind of is it clockwise or anti-clockwise? What kind of flow will they see? Right? Think, imagine, right? This is front of you, this is going back, front and back. So what kind of current are they seeing? So you can see that it is, yes, clockwise, something like this, is it not? So clockwise has what? Yes, it is south end. So this is south end and this is north end. That's how you can determine. Here, right? Again, draw a circle, almost circle. You have current going up and down. So this is your clearly north end. So if I happen to stand over here, I'm looking at a north end. Is it not? Okay, so yes, that's how you can determine if end will be north or south. So you can draw this for any given solenoid. You have to be careful with which is north end and which is south end, and you have to remember, imagine this part to be a bar magnet, right? And then think about, okay, what happens over here? You know, something like that. So one thing that you have to, okay, that comes in property. Let me not confuse you guys as of now. All you have to do is, if you guys are comfortable drawing this, you can do this. Okay, all of it, whatever you want to make a running note. So this is series battery connected in series, cells connected in series, right? That's how the each loop will act like. Is it not? Not cells, sorry. This is magnet connected in series. One after another, that's what I mean. So it will act like a single bar magnet. Acts like single bar magnet. Make sense? And here you have an exam oriented diagram, which is quite simple. So try to draw this in your exams. Okay. If possible, if you guys are able to do it dotted, right? If you have the patience and time, you can do dotted over here, then doing loopy loop. So draw a light loop first and then take your HB pencil, right? I think it's HB only, dark pencil, that's what I mean. And trace it and make it dotted over here. And yes, straight lines, a curved line, this is good enough. And depending on the current, you have to determine if it's this end is north or this end is north, and accordingly put the arrows. So I can put a few more arrows. Yeah, that will help. Is it not? Okay, so end of it, you guys need to copy, everyone has to copy this.